for the null space of the matrix A. So null space means the solution of this equation, this AX equals 0, okay, of this matrix equation. And we need to write the solution in parametric vector form. Then we can find the basis. So for that we need to put this into augmented matrix. AX equals 0 means this A colon 0. So the augmented matrix would be 1, 5, negative 4, negative 3, 1, colon 0. Okay, just 0. I'm adding 0 here. 0, 1, negative 2, 1, 0, 0, 0, 0, 0. Oh, all 0 equals 0. Okay, this is the corresponding augmented matrix. Now we need to put this into row echelon form or reduced row echelon form. I mean, echelon form would be fine. For that we need pivot. Okay, that's here 0, 0, and pivot 0, and down here pivot. Okay, on this row there is no pivot. Okay, that's good. Still we have 0 equals 0. So we got, this is already in reduce in echelon form. Okay, not the reduce but echelon form. That's enough. Okay, x1, x2, this is x3 which is free, x4 which is also free, x5 free. Okay, these are free variables because we don't have pivot. Here x1, x2. So this implies, now the solution is, so we are solving this. So here from the second row, 1x2 minus 2x3 plus 1x4, 0 means nothing, equals 0. Isolate x2. Okay, that's x2 because other variables are just free variables. So add and subtract. So we get x2 equals 2x3 minus x4. Okay, that's it for that. From the first row, 1x1 plus 5x2 minus 4x3 minus 3x4 plus x5 equals 0. Okay, we got x3, x4, x5, x3, x4, x5 free. x2, we can plug the value of x2 from previous line. So let me write this way. x1 plus 5 times x2 is this. Let's distribute 5. Okay, so we can skip one step that way. 5 times 2, 10x3 minus 5x4. Then we got minus 4x3 minus 3x4 plus x5 equals 0. We are solving for x1, right? And I think we can combine 10x3, negative 4x3, 5x4, 3x4. So x1, that is 6x3 minus 8x4 plus x5 equals 0. Now we can isolate x1. Subtract 6x3 from both sides, add 8x4 on both sides, subtract x5. So x1 is here, x2 is found here, and x1, x3, x4 and x5 are just free variables. Thus the solution x is, in fact, that means x1, x2, x3, x4, x5. That is now x1 got a lot of terms here, negative 6x3 plus 8x4 minus x5. x2 is found here, 2x3 minus x4, 2x3 minus x4. x3 is just x3 because free variable, x5. Now we want to write this in parametric vector form. We got x3, x4, x5. x3, x4, x3, x4, x5. So we can factor x3 out, okay, and then we can factor x4 out, that's free variable, and we can factor x5 outside, okay, that's another free variable. From the first x3, how many? Negative 6 copies. Negative 6 x3, 2 x3, 2, 1 x3. There are none, no x3 in the last two rows, so 0, 0. x4, 8 x4, minus 1 x4. Here is none, x4 1, and none. x5, okay, this is negative 1. x5, negative 1 copy. There is no x5 in the second row, 0, none, none, and x5 is just 1 copy. Okay, this is the solution of the given matrix Ax equals 0 in parametric vector form. So these vectors in fact form the basis for the null space. Okay, so basis for the null space of A, which is null A is just a collection of three vectors. So collection we can write in terms of inside the braces. Negative 6, 2, 1, 0, 0, comma 8, negative 1, 0, 1, 0, and okay, let me erase, I don't have room here. Then the third is negative 1, 0, 0, 0, 1. Okay, there's 3. So 3-dimensional impact, because there are 3 basis vectors for null A. The dimension of null A will be 3. Final